Show that the area of triangle formed by the lines y equal to m1x plus c1 and y equal to m2x plus c2 and x equal to 0 is c1 minus c2 the whole square divided by 2 modulus of m1 minus m2. Okay, so the first equation, write the first equation y equal to m1x plus c1, which is equal to equation number 1. Second equation y is equal to m2x plus c2, equation number 2. Third equation x equal to 0, which is equation number 3. We know that generally a triangle has 3 vertices. The vertices are x1 y1, x2 y2 and x3 y3. Okay, so from the given information, from x3 y3. Okay, so the vertices are x1 y1, x2 y2 and x3 x2 y2 and x3 y3. Okay, so from the given information we are going to find the coordinates of the triangle, which is formed by the 3 given lines. Okay, so to find the vertices of the triangle we have to solve the given equations. Okay, first by solving equation 1 and 2. Okay, equation 1 and 2, equation 1 and 2, to solve this equation we can equate equation 1 and equation 2, since the LHS of both equations have y. Okay, so m1x plus c1 equal to, this is from equation 1, m1x plus c1 equal to m2x plus c2, which is equal to y. Okay, we can equate the y coordinates of both equations 1 and 2. So we get m1x plus c1 equal to m2x plus c2. So the next step is moving this m2x to this side and move this c1 to this side, so it will become m1x minus m2x equal to c2 minus c1. Okay, now take x to outside, common to outside, so x into m1 minus m2 is equal to c2 minus c1. From this we can find x equal to c2 minus c1 divided by m1 minus m2. Okay, so x equal to c2 minus c1 divided by, move this m1 minus m2 to the denominator, so m1 minus m2. Okay, so x equal to c2 minus c1 divided by m1 minus m2. Now we have to find the corresponding y coordinate. Write equation 1 or 2. Okay, from equation 1 or 2, because we are solving equation 1 and 2, so using equation 1 or 2 we can find the y value. Okay, so x value already we have calculated. X is equal to c2 minus c1 divided by m1 minus m2. So write the equation 1, y is equal to m1x plus c1. In this equation put the value of x which we have calculated just now, equal to m1 into the value of x2 is, x is c2 minus c1 divided by m1 minus m2 plus c1. Okay, now taking LCM, m1 into c2 minus c1 plus c1 into m1 minus m2 the whole divided by m1 minus m2. Okay, so now multiplying m1 into c1 equal to m1 c1, m1 into minus c1 equal to minus m1 c1, c1 into m1 equal to m1 c1, c1 into minus m2 equal to minus m2 c2 the whole divided by m1 minus m2. Okay, now cancel minus m1 c1 plus m1 c1, so that is equal to y equal to m1 c1 minus m2 c2. Okay, these two terms are cancels each other, so y is equal to m1 c1 minus m2 c2 m1 c2 minus m2 c1 the whole divided by m1 minus m2. Okay, so therefore the point of intersection of the lines 1 and 2 is x1 comma y1 equal to the value of x is c2 minus c1 divided by m1 minus m2, and value of y is, that is y1 is m1 c1 m1 c2 minus m2 c1 the whole divided by m1 minus m2. Okay, now solving equation 2 and 3. Okay, so equation 3 is x equal to 0. Okay, now we have to solve the equation 2 and 3 to find the coordinates of x2 y2. Okay, so by using equation 2 and 3, put x equal to 0 in equation 2. The equation 2 is, in the equation 2 we have to put x equal to 0, so the equation 2 becomes y is equal to m2 into 0 plus c2, so y equal to c2. Okay, so we have calculated the coordinates of x2 y2, that is the point of intersection of the lines 2 and 3 is x2 y2 is equal to 0 comma 0 comma x2. Here the x coordinate is already given, which is 0, so for x2 we can write 0. From this we can calculate the y value, which is y2, which is equal to c2. Okay, so now we have to solve the equations 1 and 3 so that we can find the third coordinate x3 y3. Okay, so put x equal to 0. Since equation 3 is x equal to 0, put x equal to 0 in equation 1, so equation 1 is equal to 1 becomes y is equal to m1 into 0 plus c1, because equation 1 is y is equal to m1x plus c1. In this equation put x equal to 0, so it will become y is equal to m1 into 0 plus c1. So the next step is y equal to c1. So the point of intersection of the lines 1 and 3 is, which means the coordinate of third coordinate x3 y3 is 0 comma c1. Okay, so area of triangle formula is half into determinant of x1 y1 x2 y2 x3 y3 x1 y1. Okay, so just plug in the values of x1 y1. So here the value of x1 is c2 minus c1 divided by m1 minus m2, and y1 is m2 y1 is, the value of y1 is m1 c2 minus m2 c1 the whole divided by m1 minus m2. Okay, similarly plug in the value of x2 y2, so which is equal to 0 comma c2. Okay, similarly plug in the value of x3 y3, 0 c1 and x1 y1. Okay, so just substituting the value in this formula we can calculate the area of triangle. Okay, so now half into and multiply these two terms. So multiplying these two terms we get c2 minus c1 into c2. Okay, the whole divided by m1 minus m2. So multiply this term and this term. Okay, multiplying these two terms it will become c2 minus c1 into c2 divided by c1 minus c2. Okay, then plus multiply these two terms, 0 into c1 which is equal to 0. Okay, then plus multiply these two terms, 0 into multiplying these two terms we get 0. Okay, minus, and then put, so the procedure is, the usual procedure is we have to multiply x1 y2 half into modulus of x1 y2 plus, and then multiply x2 y3 plus, and then multiply x3 y1. After multiplying these terms, enclose it within a bracket and then put a minus and then open bracket, multiply y1 into x2 plus y2 into x3 plus y3 into x1. Okay, so similar calculation has to be done in this area. So we get, if you multiply these two, we get c1 minus c2 into c2 the whole divided by m1 minus m2 plus 0 into c1 0 plus 0 into this term will be equal to 0, and enclose this within a bracket, minus open bracket, multiply these two terms. So here we have a 0, so it will become 0, c2 into 0 it will become 0, and c1 into this term, c1 into c1 2 minus c1 the whole divided by m1 minus m2. Okay, so the next step is equal to half into 0 plus 0 0 0 plus 0 0. So this term becomes c2 minus c1 into c2 the whole divided by m1 minus m2, and put this minus to here, remove the bracket. Here the balance is c1 into c2 minus c1 the whole divided by m1 minus m2. Okay, now c1 we can take the common element c2 minus c1, c2 minus c1, m1 minus m2, m1 minus m2. So we can take c2 minus c1 divided by m1 minus m2 as common. So in the first element c2 is remaining, and in the second, except the common element, we have c1. Okay, so the next step is equal to half into modulus of c2 minus c1 the whole divided by m1 minus m2. Here the balance is c2, and then minus, and here the balance is c1. Okay, so c2 minus c1. So c2 minus c1 into c2 minus c1 equal to c2 minus c1 the whole square the whole divided by m1 minus m2. So from this, since the numerator has square of the element c2 minus c1, we can remove the determinant, okay, magnitude. So modulus of c2 minus c1 the whole square divided by modulus of m1 minus m2. Since c2 minus c1 the whole square, we can remove this modulus, okay, in the numerator only. So c2 minus c1 the whole square divided by 2 into modulus of m1 minus m2. Okay, so hence proved. Okay.